Yeah, sure. I will see. But you can hear the derivation.
So particle is having wave function psi inside the boundary condition. So psi when x is equal to 0, it becomes 0. So when psi value when x की value अगर 0 होती है तो then you will get that it becomes 0. Okay, particle is not present there. So apply to equation number 2. We are applying this boundary condition, that is psi of x is equal to 0 is equal to 0 for the equation number 2. What is our equation number 2? Equation number 2 is this one. Psi is equal to a sine of kx plus b cos of kx. So this is our equation number 2. We have put this boundary condition on this, put this value of x become 0 on this equation. So my equation becomes a into k and put the value of x as a 0. So I got this equation k into 0. So this whole term becomes 0. Okay, plus b into cos of k into 0 is equal to 0. But cos of, so this k multiplied by 0 means 0. But what is cos of 0? Cos of 0 means 1. We know that. Cos value of something, cos 0 is always become 1. Then my equation becomes this term becomes 0 plus I got this b and this become 1. Okay, so what I am getting, b becomes 0. Okay, so b is equal to 0, that I got here after putting the value of x is equal to 0 in the boundary on this equation. So my equation becomes, so what is my equation? Equation 2 becomes, what is equation number 2? This is psi is equal to what? Psi 1. Agar b put this value of b is equal to 0 in equation number 2. What is equation number 2? This one. So यहाँ पे b की value 0 put करेंगे तो I will get this value becomes whole becomes 0. Then I am getting psi is equal to what? Psi is equal to a into sine of kx. A into sine of kx. So this is the value I am getting after putting the value b is equal to 0 on this equation, on equation number 2. Okay. So after putting this value of b is equal to 0 in the equation number 2, I am getting the final equation, that is psi is equal to a into sine of kx. Okay, and this term becomes 0 here. So this is the equation number 3 I got here. यहाँ पे मुझे equation 3 मिल गया है. So I had given it as a equation number 3, this name. Now put the boundary condition x is equal to L. अभी हम boundary condition क्या है? अभी x is equal to L हम put करेंगे. First of all, I had taken x is equal to 0. Now I will take x is equal to L. Okay, this is the boundary condition I am taken for the equation this. For the equation number 2. Okay, after taking this boundary condition x is equal to L on the equation number 2, my equation number 2 is this one. So instead of this x I am putting it as a L. यहाँ पे मैं L put करूँगा. Then what equation I am getting? Put this value of x is equal to L in this equation. So I am getting capital A into sine of k into capital L is equal to 0. So this a value is the constant. So 0 upon constant becomes 0. So you will get, you can say that sine of kl is equal to 0. Okay. So what is this sine of kl shows? Sine of kl shows the wave. Sine of this is the wave we have. तो साइन ऑफ के एल क्या शो कर रहा है? दिस इज द वेव दैट इज वी आर गेटिंग, दिस इज द साइन वेव, साइन वेव शो कर रहा है। उसका ओरिजिन क्या होता है? द साइन वेव ऑलवेज स्टार्ट विद द ओरिजिन 0, ओके, एंड कॉस इज स्टार्टिंग विद दिस फ्रॉम 1, ओके। कॉस वेव, कॉस कहाँ से स्टार्ट होता है? 1 से स्टार्ट होता है। If such a kind of wave, that this is called as the cos wave, okay. But it is starting from the 0, so it is the sine wave. You just remember this point. So I am getting this equation, that is nothing but the sine wave, okay. So in this equation, sine of theta, theta means this scale value, sine of theta is equal to what? 0, okay. साइन पहले क्या है? 0 है, फिर क्या होता है? 2, देन इट बिकम्स पाई, ओके, देन व्हाट? साइन इज 2 पाई, देन 3 पाई, so like this. So theta value becomes plus minus 0 plus minus pi plus minus 2 pi plus minus 3 pi, but we are not considering the negative value, we are considering only the positive value. So instead of taking this, I had removed this negative sign and I had just taken the positive values. Now we are applying this rule for this KL value. Then KL value becomes, what is the KL value of this sine wave? KL value is also 0 plus minus pi plus minus 2 pi plus minus 3 pi, okay. But KL value should not be 0. KL value should not be 0, okay. If this KL value becomes 0, then what happens? Your whole function becomes 0, okay. ये आपका पूरा जो psi, if you take this KL value here, if this value becomes 0, then what happens? Your whole psi becomes 0, okay. So this should not be happen. ऐसा हो नहीं सकता कि वेव आपको मिलती है, मीन्स यू आर गेटिंग द पार्टिकल इज देयर, पार्टिकल है तो वहां पे समथिंग वन वैल्यू शुड बी देयर. इफ योर होल इक्वेशन शोइंग 0, इट मीन्स पार्टिकल इज नॉट देयर. तो अगर आपका आंसर यहाँ पे पुट करके 0 आता है तो इसका मतलब क्या होता है? पार्टिकल इज नॉट प्रेजेंट, ओके, ऐसा होता है. बट पार्टिकल इज प्रेजेंट, सो दैट्स व्हाई we are not taking this value. If KL is equal to 0, we are not considering that one. So we are considering KL becomes, either it will becomes pi, 2 pi or 3 pi, okay. तो KL की वैल्यू pi होगी, 2 pi होगी, 3 pi होगी, but K की वैल्यू 0 नहीं होगी. So this is we are consider here. So this is not possible that it means that particle is not present but particle is present. तो KL की वैल्यू 0 मीन्स व्हाट? KL की वैल्यू 0 नहीं हो सकती. अगर आप KL की वैल्यू 0 लेते तो क्या हो जाएगा? पार्टिकल इज नॉट प्रेजेंट, ऐसा उसका मतलब निकल के आता है. बट तो दैट्स व्हाई वी आर टेकिंग इट एज अ पॉजिटिव वैल्यू, पाई वैल्यू, पॉजिटिव वैल्यू वी आर कंसिडरिंग. देन व्हाट इज द योर K इज इक्वल टू व्हाट? यू विल गेट n pi upon L. N means 1 2 3 4, okay. N means this 1 2 3 4 like that. So that's why this is continuous. So this wave is become continuous, 2 pi 4 pi 5 pi like this. So we have taken this term K is equal to what? N into pi. N means 1 2 3 4, okay. 0 हम consider नहीं कर रहे. So what is the value of K? K is equal to n pi upon L, okay. तो here negative term removed, यहाँ पे नेगेटिव टर्म हम रिमूव कर रहे हैं. सो इट इज नॉट गिव एनी इंफॉर्मेशन, ओके. नेगेटिव टर्म क्यों रिमूव कर रहे हैं? बिकॉज इट इज नॉट गिविंग एनी इंफॉर्मेशन, so we are removing that one. Now our equation sine of minus kx is equal to what? We know that this sine of anything minus kx is equal to constant value of is equal to what? Minus sine of kx. आप उसको इस तरीके से लिख सकते हैं. So writing out this sine of minus kx as a minus sine of kx, okay. You just remember this point. then value of kn becomes, since these are the n number of values, so you can give it as a n kn, usko aap kn bhi bol sakte hain. That is, if an is equal to 1, then it becomes k1. If n is become 2, then this is the value of n2 that you are getting, like this. So you can give the name as a kn. Instead of writing this k, I am giving it as a kn. So kn is equal to n pi upon l, where n is equal to 1, 2, 3 dash dash dash. Now finally the eigen function is, now what is the eigen function we have? Eigen function क्या है हमारा? Psi of n is equal to a into sin of n pi l upon x. This is eigen function के कहाँ पे? Okay. So this is the equation we have derived. Sin a into sin of kl is equal to 0. So we have put the value of k in that equation. So my equation becomes psi of n is equal to a into sin of n pi l up into x, where n is equal to 1, 2, 3, 4. So this is the equation number 3a I had given. उसको मैंने इक्वेशन दिया है 3a. Okay, normalizing the wave function, because wave function also satisfy other bounds statistical interpretation. So what we will do the normalize the wave function. उसे हमें normalize करना है. So how we are doing the normalization of the wave function? By taking the limit minus infinity to infinity. Okay, and take the complex conjugate of this wave function. So psi of n becomes psi star into psi dx is equal to 1. This is the probability that particle is present. So हमें जो फंक्शन मिलता है ऐसा है, उसको हम नॉर्मलाइजिंग करेंगे. सो नॉर्मलाइजिंग द वेव फंक्शन, बिकॉज वेव फंक्शन आल्सो satisfy other bound statistical interpretation. Okay, so we are just normalizing this wave function by the psi star. Okay, taking the complex conjugate of that one. So take the limit minus infinity to infinity psi star into psi dx is equal to 1, and this is called as the probability. Now to find the probability of the finding the particle, so where we are finding the probability हमें कहाँ पे मिल सकती है पार्टिकल की होने की चांसेस कहाँ पे? In this region between 0 to L. Okay, above this there is no any possibility, and this normalization function minus infinity to plus infinity ये क्या शो कर रहा है? Particle will be present in the universe. Particle कहीं भी हो सकता है. So particle होने की चांसेस क्या है? It will be very high, minus infinity to plus infinity कहीं भी हो सकता है. लेकिन हम कहाँ पे होने के चांसेस हमने ढूंढ के निकाले, that we have particle may be present in this region x is equal to 0 to L, इसी के बीच में हो सकता है. Okay, it is not present in the minus infinity to plus infinity, या इस एरिया में नहीं होगा. सो कहाँ पे होगा? इस एरिया में होगा. सो मैथमेटिक्स में हम उसे कैसे रिप्रेजेंट करते हैं? तो वी आर रिप्रेजेंटिंग दैट विद द इंटीग्रेशन. उसको हम लिमिट अप्लाई करते हैं. सो इंटीग्रेटिंग विद 0 टू L, यानी इन दिस रीजन में क्या हो सकता है? पार्टिकल विल बी प्रेजेंट. सो वहां पे प्रोबेबिलिटी क्या है हमें? सो 1 shows the probability. 1 is the showing the probability. 0 means what? Particle is not present. So probability में आपको दो ही आंसर मिलते हैं. You are getting 0 और 1. Okay, there is no in the middle कि पार्टिकल होगा नहीं होगा, ऐसा कुछ नहीं. एक तो बताओ पार्टिकल होगा या नहीं होगा. So we have taken that particle is present in this region. Okay, because we have taken this region जहाँ पे पार्टिकल होने की संभावना क्या है? 1. So the wave function is, what is our wave function? Psi of x comma d. This is the original function of the wave. Okay, which is equal to psi of x into e raised to minus I et upon h cross. So in this wave function, this value is called as the wave function, and this is called as the eigen function. Okay, this psi, this is a small psi, you can say small psi क्या है, eigen function represent कर रहा है, और ये क्या है, total function represent कर रहा है, total function, because यहाँ पे position भी है और time भी है, यहाँ पे से position है. Okay, so this is the equation that we have taken. That is the wave function is represented by this equation. This is the wave function of the this particle उसकी wave function है, particle present in the inside the box between the 0 to L. Okay, so this function is represented by this one. Mathematics में हम ये जो wave है इसको ऐसे represent करते हैं. Now put in equation number 3 in this equation. So put the value of equation number 3 in this equation. What is equation number 3? This one. Psi is equal to a into sine of kx. Put that here. थ्री ए चाहिए था ये. 3a हमने डिराइव किया ना, this one. Put the value of 3a. Okay, that is psi n is equal to a into sine of n pi x upon l, n pi upon l into x. Put this 3a value, यहाँ पे a लिखो. Put the value of 3a in above equation. यहाँ पे a लिखना चाहिए, 3a. So my equation of the wave function becomes psi of x comma t is equal to a into put this value of psi of x की value हमें put करना है. So what is this value? A into sine of n pi x upon l into e raised to, ये वैसे के वैसे रहेगा, e raised to minus I e into t upon h cross. Okay, so this is the equation number 4a I got here. तो यहाँ पे मुझे 4a equation मिल जाता है. Put this in equation number 4. Put this value of psi function on the equation number 4. Equation number 4 क्या है? This one, normalizing wave function. So psi star की value means original wave की value, उसका complex conjugate लेना है, यानी sign change करना है. यहाँ पे sign change होगा. So I had taken that value, it has a positive. यहाँ पे जो नेगेटिव वैल्यू है उसको हम क्या करेंगे, पॉजिटिव करेंगे. ओके, नॉर्मलाइज करते हो क्या करते हम, साई स्टार मीन्स व्हाट, साई स्टार मीन्स नेगेटिव को पॉजिटिव करते हम. ओके, सो नेगेटिव वैल्यू बिकम्स पॉजिटिव. So you can write it as a psi star here, this psi star value. So ये जो इक्वेशन है हमें, यहाँ पे हमने सिर्फ साइन चेंज किया है. So put this value here. So equation number 4 becomes, so this is my equation number 4. So psi star, here we have normalized the thing. So I am getting the a into sine of n pi x upon l into e raised to plus, instead of this I will put here plus I into e small t upon h cross. This is small t here. Multiply by, what is, this is the psi. Psi means this value, a into sine of n pi x upon l into e raised to minus I into e into t upon h cross dx, which is equal to 1. Okay, so this is my equation. Apply the limit 0 to l. Psi star means change the sign of this psi value, multiply both the things with respect to dx is equal to 1. This is my equation. So this is, which is equal to 1 here. So in this equation, what is this value? This value shows the wave function and this value shows the eigen function. ये value क्या represent कर रही है, eigen function कर रही है between 0 to l. यहाँ पे 0 to l चाहिए था. यहाँ तक समझ में आ गया सबको? Hello, students.
Yes,
We
yes,
have
sir.
Yes, sir.
we have derived this equation
Yes.
yesterday also. Yesterday हमने ये derive किया था. अभी थोड़ा सा change मैंने किया है इसमें. Means ये हमें square root of ये कैसे आया ये आज मैं आपको बताता हूँ. How this a is equal to square root of 2 upon L is came. Yesterday we had just taken this equation. उसका solution कैसे आया वो बताया नहीं था. दैट ए की वैल्यू आपकी ये आती है ऐसा मैंने बताया था. सो कैसे आती है वो मैं आज आपको बताता हूँ. सो दिस इज द इक्वेशन दैट वी आर गेटिंग, दैट इज द नॉर्मलाइजिंग वेव इक्वेशन. आई विल रब दिस सो it is looking very dirty. Okay, so this is our normalizing wave function, and we have taken psi star value, psi star showing the changing the sign of this psi function. यहाँ पे माइनस है तो प्लस, we have taken it as a plus. So after solving this equation, what we will get? A square. A is common. I will take it as a square. Apply the limit 0 to L. Sine square. This is sine. This is sine. So sine square. It becomes sine square. Sine square of n pi x upon L into dx. This value become cancel out because यहाँ पे plus है, यहाँ पे minus है. So both this way, if you multiply this with this, then both the value will get cancel out. Okay. So I am getting this equation, a square 0 to L sine square of n pi x upon L into dx is equal to 1. Okay. So this is dx here. With respect to x हमने limit किया है. Trigonometric condition applying to the above equation. What is trigonometric condition? Sine square of anything means sine of sine square of theta is equal to what? 2 times sine square of theta minus 1. Okay. Sine square of theta means this is a theta value you can say. So sine square of theta is equal to what? 2 times sine square of theta minus 1. This is the trigonometric function. मैथमेटिक्स का जो रूल है वो हमने ये इस इक्वेशन में लेना है. Now I will rearrange this term. Sine square of theta is equal to what? 1 upon 2. ये यहाँ पे जाएगा तो क्या हो जाएगा? इस साइड लेफ्ट हैंड साइड में 1 हाफ हो जाएगा. दिस इज इन द न्यूमरेटर. इधर जाएगा तो डिनोमिनेटर में चला जाएगा. एंड देन दिस इज द नेगेटिव 1 आई हैड हियर. इधर जाएगा तो क्या हो जाएगा? पॉजिटिव हो जाएगा. ओके. Then my equation becomes 1 half 1 plus sine of 2 theta is equal to sine square. Sorry, this is ये 2 theta है. Sine of 2 theta is equal to 2 times sine square of theta minus 1. ये 2 है, square नहीं है, ये 2 है. So my equation becomes 1 half into 1 plus sine of 2 theta is equal to sine square of theta. So this is the equation I am getting here. Okay, this is the trigonometric equation I am getting. Now I am applying this trigonometric equation here. यहाँ पे मैं apply करूँगा. So sine square of theta I am writing it as a 1 half into 2 into sine of 2 into theta value means this one. Okay. So sine square की जगह पे ये मैं I will write like this. So my equation this equation becomes, इसको नाम दिया तो so by applying this trigonometric trigonometric condition I am getting this and rearranging this term I am getting the sine square of theta. So put this value here in this equation. So apply the limit 0 to L. A square is common. A square is common. I had taken out of the limit and put the value of sine square as 1 half into 1 plus sine of 2n pi x upon L dx is equal to 1. Okay. यहाँ पे सिर्फ थीटा की जगह पे मैंने 2n pi x upon L पुट किया है. Now we are applying the limit to this bracket term. अभी हम we will take the integration of this bracket term. अभी हम क्या करेंगे? उसका integration लेंगे. So a square up by 2 is the common, and this dx multiply with this 1, so it becomes dx. Okay, ये dx का हम क्या कर रहे हैं, मल्टीप्लाई कर रहे हैं ब्रैकेट टर्म से, तो दिस बिकम x इक्वल 0 to l dx, a square by 2 कॉमन हो गया है, प्लस a square by 2 into integration of 0 to l sin of this value with respect to dx is equal to l. हमने अभी हम क्या करेंगे, इंटीग्रेशन करेंगे. व्हाट इज द इंटीग्रेशन ऑफ दिस, dx का इंटीग्रेशन क्या हो जाएगा, 1 से हो जाएगा 0 to l. ओके, a square by 2 dx का इंटीग्रेशन क्या होता है, 1 से होता है 0 to l, प्लस a square by 2 इज द कॉमन, इंटीग्रेशन ऑफ दिस साइन, इंटीग्रेशन ऑफ द साइन इज व्हाट, साइन फंक्शन का क्या इंटीग्रेशन होता है, l upon 2n. this is the constant term we have, ये constant term है, sorry, this is the constant term we have. Okay, and we are taking the integration with respect to x, with respect to x हम इंटीग्रेशन कर रहे हैं. so इसका इंटीग्रेशन क्या होता है, कॉमन कांस्टेंट टर्म टेक आउट ऑफ दिस इंटीग्रेशन, देन इट विल बिकम्स, ये न्यूमरेटर में चला जाएगा और ये डिनोमिनेटर में चला जाएगा. सो a स्क्वायर बाय 2 इंटू एल अपॉन 2n पाई, कांस्टेंट टर्म मैंने बाहर निकाला, और इसका इंटीग्रेशन क्या होगा, साइन का माइनस कॉस, तो इंटीग्रेशन ऑफ साइन इज माइनस कॉस ऑफ 2n पाई x अपॉन l up between the 0 to l is equal to 1. Okay, now apply the limits. We are applying the limit 0 to l on both the on this equation. So my equation becomes x की वैल्यू क्या हो जाएगी, l minus 0, or you can say l. So a square by 2 into l, I am getting here a square by 2 here. So this 2 में multiply करेंगे तो क्या हो जाएगा, 4 हो जाएगा. a square l upon 4n pi, this is the constant term we have, and I had taken this negative out of the bracket, so this value, यहाँ पे मैंने वो negative sign ले लिया है. Okay, so I had taken the negative outside the bracket, so I got this equation, cos of 2n pi x, put the value l here. Okay, x की वैल्यू क्या होगी, पहले l होगी और फिर बाद में 0 होगी. So put this value, apply the limit l and 0 here. So cos of 2n pi into l upon l minus cos की वैल्यू अभी क्या होगी, 0 होगी. see x की वैल्यू 0 है, put that in the limit, minus cos of this minus this is equal to cos of 2n pi into 0 upon l. So this 0, it means cos whole term becomes 0. ये पूरा क्या हो जाएगा, constant multiply by 0, you will get the 0. So cos 0 is nothing but the 1. Okay, similarly here this l will get cancelled out, and this is the constant value we got here, and which is equal to 1. so ये 1 भी लिखना है आपको, which is equal to 1. so we are getting this equation. So finally we are getting a square by l, a square l upon 2 minus this value, constant value here, a square l upon 4 pi n, and this whole term become 1. Okay, ये पूरी टर्म क्या है, 1 होती है, 1 minus 1. so this 1 minus 1 is equal to 1. So 1 minus 1 becomes 0. Okay, so 0 here. So my equation becomes a square l by 2 minus this 0 value is equal to this 1 minus 1 becomes 0. So multiply with the constant. So whole term becomes 0 here, which is equal to 1. So that you can say that a square l upon 2 is equal to 1. Okay. So you can say that a square l upon 2 is equal to 1. Now take this 2 and l on the right hand side. ये न्यूमरेटर में, ये डिनोमिनेटर में चला जाएगा और ये न्यूमरेटर में चला जाएगा. Then a square is equal to what? 2 upon L, and I am finding the amplitude A. A is what? Amplitude. A is equal to what? Square root of 2 upon L. Okay, A square है तो ये क्या हो जाएगा? Square root हो जाएगा. So this is the equation I am getting of A. A is equal to what? Square root of 2 upon L. Now our function, eigenfunction solution, put this value in the equation number 3A. Put this value of A in equation number 3A. What is equation number 3A? We have equation number 3A क्या है? This one. Psi of n is equal to A into, that is the eigenfunction. We have A into sine of n pi x upon L. Put the value A as the square root of 2 upon L. 2 upon L की यहाँ पे मैं put कर रहा हूँ. So this is the equation I am getting, where n is equal to 1, 2, 3, 4 like that. So the final wave function in equation number 4A, put this value of A in equation number 4. Okay, A की value square root of 2 upon L in equation number 4A में put करता हूँ. So this is for the eigenfunction and the final wave function. Final wave function में put करने के बाद I am getting this equation. Psi of x, psi function of x comma t is equal to square root of 2 upon L into sine of n pi x upon L into e raised to minus I e into small t upon h cross. So this is my equation, where n is equal to 1, 2, 3, 4 like that. So the eigenfunction figures, so we will see. So this is the final equation we are getting for the wave function. Okay. So this is showing the amplitude of the wave. This is showing the how this wave function, that is size. तो यहाँ से आपको साइन वेव का सब इंफॉर्मेशन, यू विल गेट ऑल द इंफॉर्मेशन ऑफ द वेव फ्रॉम दिस इक्वेशन. इक्वेशन से आप कैलकुलेट कर सकते हैं. So the graph of this, what is the nature of the graph? We will see. Psi 1 of when n is equal to 1. Okay, n की वैल्यू अगर 1 होती है, so you will get such a kind of graph. आपको इस तरीके से ग्राफ मिलता है. So energy is maximum here. E1 is the energy of the wave between the 0 to L. Limit क्या है? X is equal to 0 to L. Now put the value n is equal to, you will get the psi function psi 2. This is the psi 2 wave function. So उसका nature क्या है? Like this. For n is equal to 3, you will get this wave. It means such a kind of wave you will get. Put the value n is equal to 4, you will get the psi. Put this value n is equal to 1, 2, 3, 4 in this equation. ये equation में put करेंगे तो क्या मिलता है आपको? You will get such a kind of number of waves. Okay. So we are getting this equation psi 1 of x, psi 1 of x. Putting the n value as a 1 here. n की value put करेंगे तो you will get this kind of equation. Psi 1 of x is equal to square root of 2 upon L sine of 1 pi x upon L. Put the value n is equal to, you will get this equation. Put n is equal to 3, you will get this equation. 4, you will get this equation. Now we will find the probability of the wave function for a particular point corresponding to the wave function. तो प्रोबेबिलिटी क्या है? पार्टिकल वहां पे रहने की प्रोबेबिलिटी क्या है? दिस इज जस्ट अ वेव फंक्शन. पार्टिकल है क्या नहीं वो हमें फाइंड आउट करना है. तो उसका नेचर कैसा है ग्राफ का? दिस इज मॉड ऑफ psi 1 स्क्वायर. मॉड ऑफ psi 1 मीन्स इट हैज ओनली पॉजिटिव वैल्यू. ओके, तो हमें सिर्फ पॉजिटिव वैल्यू कंसिडर करना है. मीन्स पॉजिटिव ही करना है. दिस पॉजिटिव, दिस इज पॉजिटिव, दिस इज पॉजिटिव. निगेटिव हमें करना नहीं है. निगेटिव हमें करना नहीं है. तो मॉड ऑफ psi 1 स्क्वायर इज इक्वल टू व्हाट? The graph is like this. Mod of psi 2 is equal to what? You will get this kind of graph. Okay. Then mod of psi 3 is like this. Put the value of n is equal to 3. Mod of psi 3 even n is equal to 4 या p n is equal to 4 है, you will get the fold number of curve. This is 3, n is equal to 3, you will get the 3 number of curve. N is equal to 2, you will get the 2 curve. So this is give the probability. Mod of psi 1 square, mod of psi 2 square, mod of psi 3 square. This gives the probability of finding the particle and is maximum at the middle. Middle में क्या है? Ground state. This is the ground state. Then first n is equal to first excited state, third excited state, fourth excited state. The probability of finding the particle is maximum at the middle. Middle में क्या है? ज़्यादा है. So particle may be present here. If you go away from this middle value, then you will find that particle is probability क्या होती है? कम हो जाती है and it becomes 0. यहाँ पे particle हो नहीं सकता. So this is the graph shows that particle is maximum present at the middle. How many time remains? Only 5 minutes. Now we will find the energy. Energy क्या है? Energy, that energy of the particle is given by this equation. Kn is equal to square root of 2me upon h cross square, where k value is equal to n pi upon l, where n is equal to 1, 2, 3, 4 like that. Okay. Now 2m en upon h cross square. Now I will take this value, compare this with this value. Okay, I am comparing both this value. K is equal to this one as well as k is equal to this one. If I compare both the value, then taking the square on the both the side, okay, taking squaring on both the side, then my equation becomes ये square root क्या हो जाएगा? निकल जाएगा. 2m e n upon h cross square is equal to n square pi square upon l square is equal to, when value of n is equal to 1, 2, 3, 4 like that. Now for the n state means energy of the, we know that this is the ground state energy, first state. This is n is equal to 1, n is equal to 2, n is equal to 3, and for this energy value is E. This is E3, E2 and E1. Okay. So energy of this wave function, you can, energy of the particle you can find out by this equation. ये equation से आपको क्या मिलता है? Energy of the particle. So for the value of n is equal to 1, 2, 3 like that. So En is equal to what? N square pi square h cross square upon 2m e. ये मैंने rearrange किया है. ओके, ये 2m अपॉन h क्रॉस स्क्वायर अगर राइट हैंड साइड में लेंगे तो क्या हो जाएगा? आई एम गेटिंग दिस en वैल्यू, ये ऊपर चला जाएगा एंड दिस 2m कम्स ऑन द डिनोमिनेटर. दिस इज कॉल्ड एज द एनर्जी, दिस इज द डिस्क्रीट एनर्जी लेवल. तो ये क्या रिप्रेजेंट कर रहा है? डिस्क्रीट एनर्जी लेवल. पुट द वैल्यू n इज इक्वल टू 1, यू विल गेट दिस इक्वेशन. n इज इक्वल टू 2 पुट किया तो ये 2 स्क्वायर हो जाएगा तो 4 मिलता है. n is equal to 3 पुट किया तो 9 मिलता है. So like this. So we are getting such a kind of graph. Okay, इस तरीके से हमें मिलता है. एनर्जी वैल्यू क्या होती जाती है? बढ़ती जाती है, डबल हो जाती है. Okay, this is 9 times, this is 4 times, this is 1 times. तो एनर्जी क्या हो रही है? बढ़ रही है जैसे जैसे you will go away from the this ground state. This is called as the discrete energy levels. No energy level is possible other than this energy level. So electron कहाँ पे है? Electron having these energy levels. इस energy level में ही electron available है. Okay. Other than this energy level, electron is not available here in this space. कहीं पे भी available नहीं, सिर्फ इसी position में. लेकिन कहाँ पे वो energy level में कहाँ पे है? This is the nucleus we have. An electron revolving this like this various orbit, n is equal to 1, 2, 3, 4, और उसकी energy level है something. So this is represent the energy level of the electron. और वो कहाँ पे? Electron is not present anywhere else. Electron is always present in this orbit. Okay. तो electron इसी orbit में है, कहीं पर भी नहीं है. So this is showing the probability. लेकिन इस ऑर्बिट में कहाँ पे वो हम फाइंड आउट नहीं कर सकते. We can't able to find where this electron, but electron is present in this energy. इस एनर्जी में लेवल में इलेक्ट्रॉन है, लेकिन उसके हमें कहाँ पे है वो हमें पता नहीं. सो दैट्स व्हाई वी हैव टेकन दिस प्रोबेबिलिटी फंक्शन. तो इसलिए हमने साई का यूज किया है, दैट इज द प्रोबेबिलिटी, संभावना. Probability means संभावना, that particle is present in this energy level. So this is the discrete energy level. No energy level is possible other than this energy level. So particle has different energy, it can have different wave function and different probability. Okay. So this is the case we have taken of the finite potential, infinite potential well. Okay, this we will see in the next lecture. Now I want to